All right, welcome to topic 6.4. We're going to do some radicals to begin with. Remember how we did this in algebra. Quick, the square root of 36, like that. You just plug in your calculator. It gives you 6. Why does the square root of 36 give you 6? Well, because 6 times 6 is 36. Okay. So this is simply 6. Now, square root of 80 is not something pretty. In fact, if I do it like that, I get this nasty number. All right, and that's not even the exact number. Decimals go on forever. This is not a good way to write this. We can write it actually in a different way. It's called simplifying the radicals. So what you do is you take the radical and you divide it. Now, you want to divide it into these things called perfect squares. For example, 36 is a perfect square. Other perfect squares, 2 times 2. Okay, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12, 13 times 13, and so forth and so on, right? And it goes forever. So you want to find these numbers that can divide out of, say, 80. All right, so what I like to do is I just like to take my 80 and start dividing and see how far I get. 80 divided by 4, all right, that works. So I could break this down into 80 divided by 4. So 4 times 20. 4 times 20 is 80. But let's see if there's any further. Can I divide 80 by 9? No. Can I divide 80 by 16? Ooh, yeah. Now that's the one I want because I can't break those down any further. So I'm going to take this 80 and I'm going to call it 16 times 5 like that, which can be broken down into 16 times 5. You can separate the root if you're multiplying. It works. So we're still the same. And now the square root of 16 it's 4 times 4, so it's 4 root 5. And there's my final answer. It's called the simplified answer. So I could do the square root of 80 and get that, or I could do 4 root 5 and get that. It's the same thing. So these are the same answer. This is just called simplified. All right. It's down to its simplest form, we call it. All right, what about 216? Okay, so 216. Let's start dividing and see what we get. Now, here's a little fun fact for you. If the digits add up to something that's divisible by 9, then it is divisible by 9. So this adds up to 9, which is divisible by 9. So one thing I could do to start this off is I could rewrite this as 9 times, let's see here, 216 divided by 9 is 24. All right, which then I can rewrite as root 9 times root 24, which is 3 root 24. But I'm not done yet. This can divide by 4. So I've got root 3 times 4 times 6, which is 3 times the square root of 4 times the square root of 6, which is 3 times 2 times root 6, which is 6 root 6. All right, there we have it, 6 root 6. Let's check in our calculator. Let's do the square root of 216, and let's do 6 root 6. There you go. Now some of your calculators do this for you. Don't rely on that because you're going to have to show your work on the test. All right. Now, there could have been a better way, but you have to know that you can't stop simplifying until you cannot divide what's in the square root by one of these numbers. You have to keep going. All right, so square root of 192. Let's see, 192. Let's start figuring it out. Now, the goal is to get the largest of those perfect squares. So 192, I know it divides by, pretty sure it divides by 4, but I think I can do better. Let's try and divide it by 16. Ooh, 16, but I can do better because that also divides by 4. Let's try 192 divided by 64. 64 times 3. So I'm going to take this 192 and I'm going to turn it into 64 times 3, which is 8 root 3. And then we can check our answer. The square root of 192. And what was it? 8 root 3. 8 root 3. And those are the same number. So I simplified it correctly. All right, this might come into play today as we work through this. First thing we're going to discuss is something called a geometric mean. And it's simply just this. If A and B are two numbers, then the geometric mean is the square root of A times B. That's it. Now, you might have to simplify. So if we've got 12 and 8, the geometric mean is 12 and 8. Now, you could break these up individually, and that would be fine too. You could call this 4 times 3. You could call this 4 times 2. But what I like to do is put it all together. 12 times 8 is 96. So I'm going to begin with this, and now I'm back up to what I was doing here. So what do I know I can divide 96 by? I think it divides by 16. Yes, it does. All right. 96 divided by 16. So 6 times 16. I'm going to call this 16 times 6. That's the same thing, which is the square root of 16 times the square root of 6, which is 4 root 6. That's the final answer for the geometric mean of 12 and 8. So all you do, square root of two numbers. Find the geometric mean of 5 and 45. Let's do that. All right, what I like to do is begin by multiplying it out. 225. All right, now that one's easy. 225 divides by 25. All right, in fact, so divided by 25, you get 9. Okay, so 225 is square root of 9 times 25, which is the square root of 9, times the square root of 25, which is 3 times 5, which is 15. Oh, you know what? If I would have plugged that in my calculator, square root of 225 is 15. All right. All right, skip 3. We don't need to do that one. Okay, next. This is why this is in this chapter. We're going to do some similar stuff. And it says this. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. Okay, so now we're going to get into some tricky stuff here. So what I mean by that, an altitude. If you take a triangle and I want to make an altitude, you go from the vertex and you measure straight down at a right angle, and this is called the altitude. All right. Also, in a right triangle, you have legs. You have legs, and you have a hypotenuse. So these are things about a right triangle that we learned a little bit in semester 1, but just a reminder. So an altitude here, so if I draw an altitude to the hypotenuse here, it would be like this. That would be an altitude. I went from the vertex, and I went straight at a right angle. That's called an altitude. So it turns out that in a right triangle, when you draw the altitude, you get 3 new triangles. So when I draw this altitude in there, when I draw this line, I now have 3 triangles. Here, here, and here. Okay? So you can see that here's the overall big triangle, triangle ABC. I've got this medium triangle right here, ABD, and I've got this small triangle here, which is BDC, like this. So now we got to come up with the similar triangles here, so you have to match it up. Now, I started with writing ABC. So what is angle A here? Angle A is this real skinny angle here. And it is shared here. This is the real skinny angle. And in this triangle, this is the real skinny angle, the real small angle there. And so A in this triangle matches up with A in this triangle, it matches up with B in this triangle. All right, next. What is B in this triangle? B is the right angle. B is the right angle. D is the right angle in this one. And D is the right angle in this one. Okay. And lastly, C would have to match up with B, which would have to match up with C again, because it's shared right here. Okay. So you see all of these triangles are similar by angle, angle. Okay. And when we have similar, we have proportions. That's why this is in this chapter. We're going to end up writing some proportions here. All right, so test question. It's going to be just like on the test here. It says identify the three similar triangles in the figure, redraw the triangles, and orient them to show corresponding sides. All right, so here's my big triangle right here. And that is triangle X, Y, Z. So I'm going to start off my statement saying, let's see, where am I going to write this? I'm going to say triangle X, Y, Z is similar. All right, now I got to pick out this medium triangle. Here's my medium triangle. In my medium triangle, W is my right angle. So I'm going to draw a medium triangle out like this. So it's matched up. Okay. In this medium triangle, W is the right angle. So I'm going to put W right here. I'm going to put Z is my skinny one. That stays out there. And then X is the one that goes up here. So then XYZ matches up with WXZ. And now for the small one. I'm going to reorient. I'm going to draw it in the same direction, just like that. What's my right angle? The right angle of this would be right there. That would be W again. The skinny angle would be the X. And the other angle would be the Y. So I drew it so that it matches up. So I can see hypotenuse, hypotenuse, hypotenuse. Short leg, short leg, short leg. Long leg, long leg, long leg. And therefore, XYZ, WXZ, WYX. There we have it. Okay, now let's actually solve some problems. Here's the problem. I'll just give you a hint. What I just did here and this problem are the questions on the test from this section. So there you have it. I'm pretty much giving you a hint because I'm absent. Okay, here's what we're going to do. We're going to begin. This is your right angle. Should have been labeled, but there it is. What I'm going to do is I'm going to start by drawing out the large triangle. All right. Now, the large triangle, this is your short leg. I'm going to put that there. This one's a little longer. So I'm going to put that there. And my entire hypotenuse, the slanted part, is X plus Y. Sorry, X plus 9. Like that. So I just took this whole triangle and just kind of went like this with it. Okay. That's all I did. Now, I'm going to take this triangle out and I'm going to make it look the same way. Okay. That's my medium triangle. Now my medium triangle has short leg 12, has long leg X, and it has hypotenuse Y. The hypotenuse is always opposite of the right angle. And then I'm going to take this one. So basically what I did was I turned it and then I kind of flipped it to put it in the right orientation. Now I've got my small triangle. And my small triangle, oh, what's this? The short leg of the medium is the long leg of the small. So 12 was the short leg of the medium, and it's the long leg of the small one. So that goes there, which makes this Z, which makes this 9. Okay, now I've got my triangles oriented, and they are similar. We just discussed that, which means I can now take and make proportions. So I'm going to solve for some stuff here. So now I've got to find some proportions that will help us out here. And here's one right here. X is to 12 as 12 is to 9. Do you see it? X is to 12 as 12 is to 9. All right, let's work this out. X times 9. 12 times 12. I'm going to write it like this. And then divide the 9. So x equals 12 times 12 divided by 9. All right, so plug that in the old calculator. 12 times 12 divided by 9. 16. X is equal to 16. Okay, now that I've got that solved for, I can go plug it in. I'm not going to call this x anymore. I'm going to call it 16. Because now we might be able to use that 16 to figure something else out. I'm not going to call this x plus 9. I'm going to call it 16 plus 9, which is 25. Okay, now we need to make some more proportions. Let's see here. What could we use as a proportion to solve? Ooh, I see one. I see one. I'm going to do 25 is to Z. 25 is to Z as Z is to 9. Notice how I'm not using two variables in a proportion. I found the proportion. All right, 25 times 9. So we're going to do 25 times 9 equals Z squared. When you cross multiply, you get Z squared. Then how do you get rid of a square? You got a square root. Which, if you have a keen eye, this is a geometric mean, which we learned about. Z is the geometric mean of 25 and 9. All right, which we can do that in our calculator. 25 times 9, like that, which is 15. Okay, now we need one more proportion to solve for, and it's going to get easier now. Now that we know that that's 15, and we know that this is 15, now we can do it pretty quickly here. So we can do y is to 16 as 15 is to 12. Like that. Y is to 16 as 15 is 12. In this case, we'll just cross multiply and divide. 16 times 15 divided by 12 is 20. Okay, study this problem because that is what you will have to do on your test. It's a 6-point problem on the test. It's a big one. These two in particular are what you have to do on the test. Let's do another one, shall we? Yes, we shall. Here we go. We're going to start by taking and making the big triangle, which has x, y, and 8 plus 25. What is 8 plus 25? 33. I didn't need my calculator for that. Okay, that's going to get gross. We have our medium triangle, which has right angle here, which means y is my hypotenuse, z is my short leg, and 25 is this one right here. And lastly, we've got this, the short one, This is my right. My hypotenuse is x. Short leg is 8. And we have z right there. So now we need to start making some proportions. You don't want to mix up your variables. I see one. Right there. X is to 33 as 8 is to x. That's an option right there. Okay, which now we cross multiply. X squared equals 8 times 33. And then you do the square root. Do the square root. So it's the square root of 8 times 33. We're just going to leave it like that for now. Square root of 8 times 33, and we'll just call it 16.2. Okay. Let's do another ratio. This time let's do y. Here's one for y right here. You see the proportion? It's going to be 33 is to y as y is to 25. Okay, we're going to cross multiply, and that is 33 times 25. You're going to square root to get rid of the square, which gives us our final answer. And we're going to call that good right there for today. 28.7. Okay, last one, we need to write a proportion for z. We need a z proportion, and this, I'm going to use my little llama to help me. That's right, I got a little llama to help me. Mr. Llama, you see a proportion? Well, why, yes I do. Right here and right here. Well, okay then. All right, let's write a proportion right here and right here. Yep, I'm gone crazy. Z is to 25 as 8 is to z. All right, there's my proportion. We're going to cross multiply. And cross multiply. And we'll do the square root to get rid of the square, which then leaves us with z equals square root of 8 times 25. 14.1. We did it. All right, very similar to a test question. You gotta take a triangle, you gotta put it into 3 separate triangles, and then you gotta start looking for proportions. It's pretty straightforward. All right, there are some shortcuts. I'm not gonna teach that to you. That's up to you if you wanna learn the shortcuts. If you can make sense of this, you can learn it. I'm gonna do just a couple more, and we're gonna call it a day. All right, so here we go. Let's look at this triangle right here. This will be like some homework problems. I'm going to take and make 3 separate triangles. We got the big triangle, which has x, z, and 6. We've got the medium triangle, which would be this one right here, which is just like it is. We've got y. If this is 2 and this is 6, this has to be 4. 4 and z. And we've got the small triangle, and so I reoriented it, shifted it around. Short leg, long leg, hypotenuse. There we have it. Now, look for proportions. There we go. Maybe Mr. Llama will help us again. You see any proportions, Mr. Llama? I don't know. Maybe right here and right here. That's right. Good job. All right, we're going to say x is to 6 as 2 is to x. That is 2, isn't it? Yeah. My z, I usually put it across through my z so I don't get it confused with anything else, right? That's a z and that's a z. So that's a 2. Sometimes my 2's look like z. So x is to 6 as 2 is to x. All right. Cross multiply. Cross multiply. 2 times 6 is 12. take the square root. You know what? Let's just call it like that. That's good enough. It's good enough for right now. Okay. All right, Mr. Llama. You see any other proportions? What about a proportion for y? All right. Let's see here. Sure, yeah. I see one right there and right there. Right there, right there. All righty. Y over 4 is 2 over y. Cross multiply. Cross multiply. And we'll just call it the square root of 8 for now. All right, what about z? Let's check out z. Well, I see one right here and right here. I'm so good, I don't even need Mr. Llama's help anymore. 6 over z equals z over 4. Cross multiply, cross multiply. 6 times 4. And for time purposes, it's just the square root of 24. All right. Ugh. See if I can get another one done in 4 minutes. So to make this a half-an-hour video. Here we go. This one, it's already lined up pretty well. Z, Y, 4 and 15 makes 19. There we have it. There's my big one. Here's my medium one. Medium's one's right here. We got X, Y, that's the hypotenuse, and 15. And we got the short one, the small one, right here. And that would be 4, Z, and X. All right. Oh, looking for some proportions. So let's start finding some proportions. Here's one. There's a proportion. We can say 19 over y is equal to y over 15. Let's look for another one. I'll just write the proportions out. I know you can solve them from there, so time purposes. What else do we got? We got, ooh, how about this one? Yep, we could say 15 is to x, as x is the 4. And there's got to be one more proportion. Solve for y. No, solve for z. And there it is right there. And right there. 19 is to z, as z is to 4. All right, just more of the same. So the process. Step 1, 3 similar triangles. Step 2, proportions. Step 3, well, actually solve your proportions. I'm gonna let you just plug in your calculator if you get weird things like this, that's fine. I will tell you this, give you another hint on the test. It's gonna be like this one, where you do get nice integer answers when you finish. All right, that is the lesson. Bye. Okay, that's really weird.